Okay, so again, we're going to go and continue this whole idea of u-substitution. But with this example, if you notice right off the bat, we have limits. We have a definite integral. I believe that all the examples we've been doing so far have involved indefinite integration. So here we're going to look at our first example involving a definite integral. And the process is pretty much the same. Nothing really changes. We just have one little thing to adjust, and I'll explain. Whoa. My bad, sorry, that shouldn't have popped up there. But I'll explain how we're going to handle these limits in just a bit. The first thing that you want to do is identify what substitution are you going to make. What are you going to let u equal? And just by looking at this problem, it just looks like I'm going to let u equal this thing right here. So I'm going to say that u is equal to 2x to the fourth plus 1. And the reason why I'm letting u equal this is because, well, if I take the derivative, sorry, that's just the bell. If I take the derivative of this, I end up with an x cubed, and I have an x cubed sitting out here. I'm going to have some constant to deal with, but I can take care of a constant. That's no problem. But the most important thing to recognize is that you have a degree of 4 here, and when you take the derivative, you'll be left with a degree of 3. So I have a degree of 3 sitting out here. Well, I'm going to start by saying u is equal to 2x to the fourth plus 1. And now what I want to do is take the derivative of that to figure out what my du is going to be. So let me go ahead and do that here. So let's say that du, if I take the derivative here, it's going to be 8x cubed, and then the derivative of 1 is just 0, so we're done, and then I tag on this dx here. Now that's really cool because I have the x cubed sitting right here, and I have a dx sitting right here. So it almost looks like what I have here. The only problem is that I have a constant of 8 here. So I want to get rid of this 8. Well, I can easily just divide. Both sides by 8. And if I divide both sides by 8, I'm left with 1/8 du is equal to x cubed dx. Now that's nice because I have x cubed dx sitting right there, so I can now make my substitution. Now, just for now, what I'm going to do is I'm going to leave the limits out of this. I'm not going to write 0 to 1. I'm going to focus first on cleaning this inside part first, and then I'll worry about my limits later. Well, let's start by making the u substitution. Well, we said that u is equal to this 2x to the fourth plus 1, so I'll have u squared now. And instead of x cubed dx, remember x cubed dx can be written as 1/8 du. So this will be 1/8 du. And because this is a constant, I can easily take it outside, and I'll have, let's see, I'll have the 1/8 here. So I'll have 1/8. And then I'll have the integral, so the integral of u squared du. So u squared, and we have this du here. So this is a lot nicer to work with. Once I've cleaned up my integral, I now want to focus on my limits. Now keep in mind that these limits, when we started off with 0 to 1, we are talking about, these are x limits. These are the limits for x. Well, remember, by making this substitution, we're now changing our variable to u. So these new limits that we're going to have are not going to be x limits, they're going to be u limits. And well, how do we figure out what the limits are for u? Well, easy. It's not very difficult at all. So all I'm going to say is, look, when x equals 0, and 0 again came from here, my bottom limit, I'm going to simply plug 0 into my x value here, or into my u function here. Well, u is going to equal 2 times 0 to the fourth plus 1. And if you clean this up, I get 1. So when x is 0, u is 1. So I'll put the 1 right here as my lower limit. I do the exact same thing for my upper limit, and I say, well, when x equals 1, again 1 coming from up there, from my upper limit, what does u equal? Well, we simply plug that into our u function here, so we'll have 2 times 1 to the fourth plus 1, which is equal to Yeah, it's equal to 3, so we'll put a 3 here. So now we have our integration, or the problem that we need to integrate, and we have the correct limits here to go ahead and evaluate that problem. So here's what we're going to do. We're going to have, let's see, this is really equal to the integral, or I'm sorry, not the integral, but I'm going to find the antiderivative here. What's the antiderivative of u squared? Well, we simply just get u cubed over 3. And keep in mind, because this is a definite integral, we are going from 1 to 3. So now all I have to do is apply the fundamental theorem of calculus and go ahead and clean this up. So this is going to equal, now I'm just going to multiply these two things. I'm going to multiply the 8 times the 3 so that, we just get, let's see, I'll clean this up one more time, u cubed over 24, and again I'm going from 1 to 3. So now I'm going to substitute my limits back in. So let's see, we're going to have, let's see, I'm going to plug in the 3 first, so I'll have 3 cubed over 24 minus, by the fundamental theorem of calculus, now I plug in the bottom limit, so I'll have 1 cubed over 24. And now if I clean this up, I know that 3 to the 3rd power, that is equal to 27 over 24. I know this here is 1 over 24, and this cleans up to 26 over 24, and you can go ahead and reduce, and we'll reduce it. If I divide the top and bottom by 2, this is equivalent to saying, let's see, 26 divided by 2 is 13, 24 divided by 2, that is 12. So here's our answer, 13 over 12.